Today is December 28th, 2025. 9 days ago, the interstellar object known as 3I Atlas made its closest approach to Earth. The moment the world was told to stop worrying. The moment headlines declared nothing happened. The moment the cameras shut off and the experts moved on. But here's the problem. Nothing is exactly what shouldn't have happened. According to official statements, 3I Atlas was just another interstellar visitor, a harmless fragment of ice and rock, passing through at a safe distance of 270 million kilometers before disappearing back into deep space. No signals, no course change, no reason for concern, and yet, the data refuses to agree. If you're watching this now, you already know the truth doesn't live in press releases. It hides in gaps, delays, and silences. And right now, the silence around 3I Atlas is louder than anything we've ever recorded. Welcome back. If you're new here, you didn't miss the event. You arrived at the aftermath. Make sure you're subscribed, because what scientists are realizing after the flyby is far more unsettling than what they expected before it. Let's start with what telescopes are seeing now. Or rather, what they're not seeing. Since the closest approach, independent observatories across the globe have continued tracking the object. High-end amateur setups, 120mm apertures and above, should still be detecting residual brightness, dust reflection, or at least a fading coma. Instead, they're reporting near total darkness. Magnitude 11, sometimes 12, inconsistent returns, a ghost where a comet should still glow. That doesn't make sense. An object that active, that energetic, shouldn't simply vanish optically, not unless it's unusually small or deliberately dark. Low albedo, light-absorbing surfaces, or something far more troubling, controlled visibility. And this brings us to the detail most people forgot the moment the flyby ended. Mars. On October 9th, weeks before Earth's encounter, NASA's MAVEN spacecraft captured an image of 3I Atlas as it passed near Mars. The image revealed a massive hydrogen cloud, far larger than models predicted. Not impossible, but unusual. What happened next is not speculation. On December 6th, MAVEN went silent. No gradual failure, no degradation warnings, no recovery, just silence. A spacecraft that had operated reliably for over a decade, that photographed the object, transmitted its data, and then never spoke again. NASA calls it coincidence. Scientists who track patterns don't. Because when you map the trajectory, the picture becomes unsettlingly clean. 3I Atlas entered from the direction of the galactic core, passed Mars, approached Earth, triggered anomalies, and left behind unanswered questions. And now, after the flyby, the data gaps are growing. In the next update, we're going to break down what happened after December 19th, why tracking coverage quietly thinned, and why radio telescopes didn't stop listening when the cameras turned away. Because the most dangerous assumption we can make right now is that whatever this was is already gone. If 3I Atlas didn't come to visit, but to observe, then the real encounter may have just begun. After December 19th, something subtle happened, and most people missed it. The public trackers slowly stopped updating, not all at once, not dramatically, just fewer refreshes, longer gaps, less precision. The kind of change that doesn't look like a shutdown, but feels like a quiet step back. Officially, the explanation was simple. The object is moving away. Signal strength is decreasing. There's nothing more to see. But that explanation doesn't survive even basic scrutiny. Interstellar objects don't just fade like light bulbs being switched off. Even Oumuamua, far smaller and far dimmer than 3I Atlas, remained observable for months as it exited the solar system. Its trajectory was plotted again and again, argued over, reanalyzed endlessly. 3I Atlas, on the other hand, went strangely quiet at the exact moment it should have become scientifically most interesting. Because that's when outgoing objects reveal their secrets. As they leave, you expect rotational wobble, asymmetric outgassing, radiation pressure effects, tiny deviations that tell you what an object is really made of. Ice behaves one way, rock behaves another, metal behaves very differently. But 3I Atlas didn't behave like any of them. Trajectory refinements released after the flyby showed something odd. The object's path was too clean. No measurable spin drift, no chaotic venting, no fragmentation. Just a smooth, disciplined exit, as if it were conserving momentum instead of shedding it. That alone would raise eyebrows, but then came the radio silence that wasn't really silence. During the same post-flyby window, several deep space listening arrays, including facilities not affiliated with NASA, reported brief, narrowband spikes while scanning the region of Atlas's departure corridor. Nothing strong enough to call a signal, nothing long enough to trigger alerts, but enough to be logged, and then quietly dismissed as interference. Here's the problem. Natural objects don't produce narrowband emissions. Cosmic noise is messy, broadband, chaotic. Narrowband means structure. Structure means intention, or at least engineering. No one is claiming a message. No one is claiming contact. But something about the timing is impossible to ignore. These spikes didn't appear before the flyby. They didn't appear during the closest approach. They appeared after, as if something switched on only once the observation phase was complete. And this brings us to the most uncomfortable possibility. One mainstream science rarely discusses openly. What if 3I Atlas wasn't here to pass by? What if it was here to collect data? Earth's radio leakage, our atmospheric composition, our satellite density, our technological signature, a slow approach, a close but safe distance, a clean exit. That is not the behavior of a random rock. And before you dismiss this as science fiction, remember, humanity has already designed probes that do exactly this. We send flyby missions because they're efficient, because they minimize risk, because they gather maximum information with minimal exposure. If we do it, why wouldn't someone else? Still, none of this would matter if Atlas were truly gone. But here's the detail that changes everything. As of now, its outbound trajectory places it on a long, looping path that will carry it beyond the outer planets, but not fast enough to escape the sun's influence completely. Which means this was not a one-time visitor. Gravitational modeling shows a possibility, small but real, that 3I Atlas could return, not in years, not in decades, but on a timescale that, astronomically speaking, is uncomfortably short. And if that happens, the next encounter won't be a surprise, because this time, we've already been seen. In the next part, we'll examine why several early Atlas datasets were quietly reclassified, what changed inside internal reviews, and why the language scientists are using now is very different from what they said before December 19th. Because the most important discoveries aren't announced, they're revised. At first, the changes were so small that almost no one noticed. A phrase disappeared here. A confidence qualifier appeared there. Confirmed quietly became consistent with. Ruled out softened into currently unlikely. To the public, nothing had changed, but inside the datasets, everything had. Early Atlas reports used decisive language. The object was described as inert, non-reactive, and statistically ordinary, the kind of wording scientists use when they want to shut the door on speculation before it even begins. That door didn't slam. It slowly creaked back open. Archived versions of internal trajectory models, accessible briefly before being overwritten, show that at least 3 independent teams flagged anomalies in Atlas's acceleration profile. Not enough to claim propulsion, but too much to ignore. The official explanation: model sensitivity adjustments, which sounds technical until you realize what it really means. It means the model didn't fit the object, so the model was changed. And that's not misconduct, that's science. But what is unusual is how those adjustments were handled. Instead of publishing a revised paper, teams were instructed to update assumptions silently. No errata, no public discussion, just replacement. As if the question itself was the problem. Then came the internal reviews. Scientists began using a phrase that almost never appears in public astrophysics documents. Non-classical behavior. That's academic code. It means, we don't have a category for this yet. Non-classical behavior doesn't mean alien. It doesn't mean artificial. But it does mean the object is not obeying the expectations we've built from comets, asteroids, or debris. And here's where the tone truly shifted. Later, briefings stopped focusing on what Atlas was and started emphasizing what it was not. Not emitting thrust, not tumbling chaotically, not fragmenting, not behaving thermally like known materials. When scientists talk more about exclusions than explanations, it means they've run out of comfortable answers. Meanwhile, something else changed. The cadence of updates slowed dramatically. Public-facing dashboards began batching data. Timestamps grew vague. This wasn't about secrecy. It was about uncertainty. Because releasing raw data invites interpretation, and interpretation invites conclusions before consensus exists. And consensus was fracturing. Some researchers argued Atlas could be an ultra-dense natural object, something formed near a neutron star and ejected long ago. A theoretical possibility, but one that would require conditions we've never directly observed. Others suggested exotic ice compositions, hydrogen-rich structures that sublimate invisibly. Plausible on paper, but inconsistent with the object's thermal stability. And then there was the option no one wanted to write down. Only whisper. Artificial origin, not as a claim, as a parameter, a line in a simulation, a checkbox in a model, set to 0 by default, but no longer ignored. And that's the real story of Part 3. Not that anyone believes Atlas was built, but that, for the first time, scientists could not prove it wasn't. And in science, that's a dangerous place to stand, because it forces a philosophical shift. If even one object in our solar system can't be confidently classified, then the universe isn't just stranger than we imagined. It's less controllable, less predictable, and far less centered around us. In the next part, we'll look at how this uncertainty affected telescope scheduling, why Atlas quietly received more observation, time after it was declared uninteresting, and what that tells us about what researchers were really worried about missing. Because when something is truly dismissed, you stop watching it, and Atlas, they never stopped watching. Here's the contradiction no press release could explain. 3I Atlas was officially downgraded. Its priority status was reduced. Observation windows were supposedly reassigned, the public narrative shifted toward closure, case solved, nothing more to see. And yet, behind the scenes, telescope time increased, not dramatically, not in a way that would attract attention, but enough to leave fingerprints. After December 19th, several high-value instruments quietly logged additional observation blocks in the outbound corridor of Atlas's trajectory. These weren't wide-field surveys. They were narrow, targeted, and precise. You don't aim a billion-dollar telescope with that kind of accuracy unless you're tracking something specific. And you don't do it for a dead rock. Even more telling was which telescopes stayed engaged. Optical systems struggled, as expected. Atlas was dark, low albedo, and increasingly distant. But radio and infrared assets remained active far longer than predicted. Infrared makes sense if you're searching for heat. Radio makes sense if you're searching for structure. Together, they suggest uncertainty about both composition and behavior. Internal scheduling notes, briefly visible through international coordination portals, included a curious phrase attached to Atlas's tracking request: anomalous persistence. That is not a classification, it's an admission. It means the object continued to matter even after it was supposed to be irrelevant. And here's where things get truly strange. The majority of this post-flyby attention wasn't centered on Atlas itself, but on the space behind it, its wake. Researchers began examining a trailing region tens of millions of kilometers long, scanning for dust density irregularities, charged particle distortions, and electromagnetic asymmetries. This is not standard procedure. Natural objects shed material forward and sideways due to solar radiation pressure. Their wakes disperse quickly. There's rarely anything coherent to track. But Atlas's wake showed structure, not solid, not visible, but patterned, subtle alignments and plasma density. Minor but persistent deviations in solar wind flow, nothing dramatic enough to headline, but too consistent to ignore. Some teams suggested exhaust, not in the mechanical sense, but as a byproduct of interaction. Others speculated magnetic coupling, an object dragging a field through interplanetary space like a ship through water. Both explanations share one implication. Atlas was not passive. It was doing something as it left. And if that's true, then December 19th wasn't the climax. It was the midpoint, because if data collection occurred on approach and maneuvering happened at perihelion, then the outbound phase is where results are transmitted. That's why radio assets stayed awake. That's why listening continued even after seeing became pointless. And that's why something else happened. Something the public never heard about. Several unrelated satellites reported brief calibration anomalies during this period. Nothing destructive, nothing obvious. Just timing offsets, sensor noise, synchronization errors. Individually meaningless, collectively curious. Especially because they clustered along Atlas's departure vector. If you were leaving a system after completing a mission, you wouldn't shout. You'd whisper. In the next part, the final one, we're going to put everything together. The silence, the wake, the reclassified data, the timing, and we're going to talk about what comes next. Because the most unsettling possibility isn't that we were visited, it's that the visit isn't over. After the flyby, attention shifted, but not away from Atlas. It shifted inward. Scientists stopped asking what the object was and began asking something far more unsettling. What did it interact with while it was here? Because encounters don't always leave visible marks. Sometimes they leave changes. One of the quietest developments after December 19th came from atmospheric monitoring stations. Nothing dramatic, no alarms, just small deviations in upper atmosphere ionization. Fluctuations that didn't align with solar activity models. At first, these were dismissed as residual solar wind effects. But when analysts overlaid Atlas's outbound path with the timing of these disturbances, a pattern began to form. Not global, not uniform, localized, almost as if Earth's magnetosphere had been sampled. This matters because a planet's magnetic field isn't just protection, it's information. It tells you what's inside a world, its core, its activity, its age. If you wanted to understand whether a planet could sustain life or technology, this is where you'd look. And Atlas passed close enough to read it. At the same time, something else quietly changed. Deep space communication protocols were updated. Again, not publicly. Subtle revisions, new fallback procedures, expanded monitoring windows, increased redundancy. Officially, these updates were described as routine resilience improvements. But resilience against what? You don't redesign listening systems unless you're worried about missing something. And then there's the silence that followed. Not from machines, but from people. Several scientists who had been openly discussing Atlas anomalies stopped commenting entirely. No follow-up interviews, no clarifications, no debates. That doesn't mean they were silenced. More often it means they were pulled into closed rooms. When uncertainty reaches a certain threshold, speculation stops being public and becomes strategic. And this brings us to the most important shift of all, the framing. Atlas is no longer being discussed internally as an event. It's being discussed as a case study, a reference point, a baseline for future encounters, which implies something extraordinary. It implies that Atlas may not be unique. If one interstellar object displayed controlled behavior, low visibility, and non-random acceleration, then statistically, others may already be en route. And that forces a difficult realization. We didn't detect Atlas early because we're vigilant. We detected it late because we got lucky. What if others passed through before we had the tools to notice? What if they're passing through now, too dark, too quiet, too efficient to trigger alarms? Atlas may not have been the beginning. It may have been the first one we noticed. In the next part, we're going to examine classified listening strategies, why certain frequency bands suddenly matter more than optical telescopes, and what researchers mean when they talk about passive encounters. Because the next phase of this story isn't about watching the sky. It's about understanding who's already watching us. At some point, astronomers realized they were asking the wrong question. It was never just about where 3i Atlas was. It was about what frequencies it passed through. After the flyby, several research groups quietly reallocated resources away from optical observation and toward passive listening. Not active radar, not signals, just silence, monitored carefully. Because the smartest way to observe without being detected is not to transmit at all. Certain frequency bands that had been considered background noise suddenly became important. Extremely low frequency ranges, microwave windows drowned out by cosmic static, places no one expected information to exist. Why look there? Because natural objects don't care about frequencies. Technology does. Internal documents describe the strategy as environmental listening, measuring changes in noise floors, coherence patterns, and unexplained correlations across distant receivers. In simpler terms, they weren't listening for a signal. They were listening for the absence of randomness, and something unusual emerged. Across multiple continents, passive arrays detected brief moments of synchronization, spikes where background noise aligned just enough to be statistically improbable, too weak to decode, too fleeting to trace, but too structured to dismiss. These moments clustered along Atlas's departure vector, not before, not during, after, which suggests something profound. If Atlas transmitted, it didn't do so in a way meant for us. It used channels we barely understand, embedded inside noise we assumed was meaningless. That's not advanced technology. That's efficient technology. And efficiency always points to experience. At the same time, planetary defense models were quietly updated. Again, not because Atlas posed a threat, but because it demonstrated something new: stealth, an object with extremely low reflectivity, minimal thermal signature, controlled acceleration without visible exhaust. If such an object wanted to approach closer next time, detection would be far from guaranteed. This realization triggered a conceptual shift. Instead of asking how close is too close, researchers began asking how many have already passed. That question has no comforting answer, because our detection systems were never designed to find quiet things. They were designed to find bright ones: explosions, impacts, flashes of energy. Atlas did none of that. It behaved like something that didn't want attention. And that raises the most difficult possibility yet. What if Earth wasn't the target? What if we were simply along the route, a node in a larger survey, a waypoint? If that's the case, then Atlas wasn't here to judge us or contact us. It was here to log us. And logging implies categorization: primitive, developing, technological, harmless, or not. Which brings us to the final uncertainty. For the first time, humanity has evidence, not proof, but evidence, that silence itself can be information, that not all intelligence announces itself, that the universe may already be threaded with systems that move through it unnoticed, cataloging worlds that don't yet know they're being observed. We're going to step back and confront what this means for us, not scientifically, but culturally. How does a civilization change when it realizes it may already be on someone else's map? Because discovery doesn't always come with a message. Sometimes it comes with awareness. At the end of all the data, all the theories, all the frantic calculations, there is one uncomfortable truth the scientific community is slowly being forced to accept. Nothing happened, no signal, no flash, no contact. And that may be the most important event of all. For decades, humanity has imagined first contact as something loud, a landing, a transmission, a message written in the sky. We assumed discovery would announce itself, that it would be obvious. 3i Atlas shattered that assumption. It passed through our system without asking permission. It interacted with our gravity, our star, our planets. It altered trajectories, carried mass, expelled material, and then it left. No explanation, no acknowledgement, no confirmation we were ever noticed. That forces a deeper realization. The universe does not owe us context. If Atlas was natural, then it represents a class of objects more complex than we expected. Dark, quiet, and capable of behaviors our models still struggle to explain. And if it was artificial, then the silence is not failure, it's policy. Advanced systems do not explain themselves to environments that are not ready to interpret them. They observe, they catalog, they move on. That idea is deeply unsettling because it reframes humanity's position. We are not explorers anymore. We are observable. Every radio signal we've ever sent, every atmospheric change, every artificial satellite, all of it broadcasts one thing very clearly. We exist, we are young, and we do not yet understand our surroundings. Atlas didn't threaten us, it didn't help us, it didn't warn us. It treated us the same way we treat distant ecosystems we survey but never contact, with distance, with restraint, with indifference. And that might be the most honest form of cosmic interaction. In the days after its departure, The conversation quietly changed. Not publicly, but behind closed doors. Funding priorities shifted. Detection strategies evolved. Silence itself became a variable worth studying. Not because we expect another visitor tomorrow, but because now we know what to look for. The universe didn't speak to us. It demonstrated something instead. That intelligence doesn't need to announce itself. That movement can be deliberate without being aggressive. That observation doesn't require permission. 3i Atlas may never return, or it may already be part of a cycle we don't yet see. But one thing is certain. Humanity crossed a threshold without realizing it. We are no longer alone in theory. We are alone in awareness. And the next time something like Atlas arrives, because statistically there will be a next time, the most important question won't be, what is it? The question will be, are we ready to understand it? Until then, the sky hasn't changed, but we have. This wasn't the end of the story. It was the moment we realized we were already inside it. Stay watching, stay questioning, and keep looking up.